Hey, video problem number 26 is over the mole. Let's go ahead and get started here. So determine the number of moles for 1.24 times 10 to the 23rd molecules of dinitrogen pentoxide. Alright, we don't necessarily need to know what dinitrogen pentoxide is in this case, but that's what it is, in case you're wondering. So we have 1.24 times 10 to the 23rd molecules, and we want to figure out how many moles are in it. Well, this is a molecule. So I can go straight from molecules to moles here. So I'm going to put moles on top, molecules on bottom. For every 1 mole, there are 6.022 times 10 to the 23rd molecules. So let's punch this into your calculator. Make sure you punch this into your calculator too so you can know for a fact that you're doing it right. So 1.24, I'm going to hit the EE button, and then 23. And I'm going to divide that by 6.022 times 10 to the 23rd. Again, I'm going to hit the EE button. And so I get a value of 0.206. Molecules cancel out, and that's moles of dinitrogen pentoxide. Okay? Look at the next one. Determine the number of moles of barium nitrate if it has 2.42 times 10 to the 24th atoms of oxygen. Now in this case, I do need to know what barium nitrate is. So there's barium. Here's nitrate. So barium nitrate is going to be BaNO3 2. So I have 2.42 times 10 to the 24th atoms of oxygen. And I want to figure out moles of this compound. So I'm going to have to go from atoms of oxygen to, let's say, molecules of barium nitrate, and then finally to moles. So let's go ahead and go from atoms to molecules. So I'm going to get molecules on top, and technically it's a formula unit, but we're fine just using that. We're going to put atoms of oxygen on bottom. This is molecules of barium nitrate, BaNO3 2. Alright, so what do we have? For every 6 atoms of oxygen, I have 1 molecule of BaNO3 2. So I'm going to take my 2.42 times 10 to the 24th, and I'm going to divide by 6. And I get a value of 4.033 times 10 to the 23rd molecules of barium nitrate, BaNO3 2. But that's not my answer because I want to know moles. So I'm going to bring this on down here. 4.033 times 10 to the 23rd molecules of BaNO3 2. Alright. So what do we have? I'm going to try to go to moles, and I'm going to get rid of molecules. Right? So for every 1 mole, there are 6.022 times 10 to the 23rd molecules. So I'm going to take my answer that's still stored in my calculator, and I'm going to divide by 6.022 times 10 to the 23rd. And I get a value of 0.670. And that's moles of barium nitrate. Now that's not the only way to do the problem. Let me show you another way to do this problem. Let's see. So another way to do this problem would be, we're still going to start, I'm going to do this in red. We're still going to start with our atoms of oxygen, so 2.42 times 10 to the 24th atoms of oxygen, right? And this time, we're going to go ahead and, let's go ahead and switch this to moles of oxygen. Sure, we can switch that to moles of oxygen, right? So for every 1 mole of oxygen, there are 6.022 times 10 to the 23rd atoms of oxygen. Right? So atoms of oxygen. So when I divide that, what do I get? 2.42 times 10 to the 24th divided by 6.022 times 10 to the 23rd. Remember to use that EE button. So that gives me 4.0186 moles of oxygen. But I don't want moles of oxygen. I want moles of the compound. Right? So I want to replace oxygen with barium nitrate, BaNO3 2. And I want to get rid of oxygen. As it turns out, for every 1 barium nitrate, there are 6 oxygens. So I'm going to take that value, divide by 6, and I get a value of 0.670 moles of barium nitrate. So same problem, two different ways to do it. There you have it.